Hi, this is Mrs. Ward, and today we're going to talk about hyperbolas. We're going to write the equations of hyperbolas, then we're going to find the asymptotes of the hyperbola and sketch them. We're going to use properties of hyperbolas to solve real-life problems, and finally we're going to classify conics from their general equations. So let's get started. First of all, we should define what a hyperbola is. So I'm going to start off with these 2 points, which are called the foci, and then if I take the distance of one point to a foci, if I take this D2 and minus this D1, those two differences are always going to be a positive constant. So you're always going to take the larger distance minus the smaller distance, and it's going to be the same number no matter where that point lies. So let's talk about the way we separate the hyperbola. We're still going to have a center like we did before. What's interesting now is the center is no longer inside my shape. The center is actually outside of my shape. I'm only going to have one set of vertices. Unlike the ellipse, I'm only going to have one set. I'm going to have these 2 points here, which are vertices. The distance from my center to my vertices are still going to be represented by the letter A. The distance from my center to my foci is still going to be represented by the letter C. You're going to notice that when I look at this graph here, I'm not going to see the letter B. I'm still using B to write my equation, but the letter B never appears on the graph. But B plays an important point on how we sketch the graph. These 2 points here, these 2 sides here, are called the branches of the hyperbola. And depending on where my B is and where my A is, it depends on how narrow or how wide those branches are. So when I start looking at the equation sheet, I'm still going to have the same x minus h squared. The h and k are still going to be my center, just like they were in the circle, just like they were in the ellipse. A key difference here is I am now going to have a minus sign. We've never had a minus sign before. So one of my variables is going to be positive, one of my variables is going to be negative, and that's what makes it sort of like a disconnected shape. The a squared, the a is no longer the largest number. A is going to go with the positive variable. So in this case, the y would be positive, the a would go with this. If the x is positive, the a would go with this. A is no longer the largest variable. So I will probably say that 3 or 4 times, but it's very important that you remember that. And the a is now going to go with the variable that happens to be positive. So make sure that you write down that you have the shapes. So when x is positive, your branches are going to open east and west or to the sides. When your y is positive, your branches are going to open up and down. You're also going to have the formula here to relate your C to your A and your B. And now this is going to be C, whoopsie, I meant to highlight. C is equal to A squared plus B squared. So that's different than it was before. In an ellipse, it was C squared was equal to A squared minus B squared. Hyperbola is C squared is equal to A squared plus B squared. Because remember, the foci is inside the branches. So the distance between here and here is going to be the largest distance that I have. So let's talk about how we find an equation. So it says the first problem says find the standard form of an equation of the hyperbola with foci at 0, 0, and 8, 0, and the vertices at 3, 0, and 5, 0. So the first thing I'm going to do is I'm going to sketch, just a quick sketch to see what is going on. So when I do that, I'm going to have a foci at 0, 0. I'm going to have another foci at 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 8, 0. So those are my foci. I'm going to have vertices at 3, 0, 1, 2, 3, 0, and 5, 0. So right there, those are my vertices. So I can either use my foci to find my center, or I can use my vertices. I notice that in every single one of these, they all lay on the same line. So that my center vertice ordered pair is still going to have that 0 for the y coordinate, because that is the same in every single one of those points. So that's not going to change at all. The center is also going to be in the middle of the two foci or in the middle of the two vertices. So let's say I chose to use the foci. I'm going to find the midpoint or the middle between 0 and 8. So I would say 0 plus 8, divide that by 2, 8 divided by 2, and I get 4. So my center is going to be 4, 0. And if I look here on the graph, that makes sense for my center to be 4, 0, because it's halfway between the vertices and halfway between the foci. So now, remember, my center is still going to be my H and my K, so I needed to find that. Since everything is happening on the x-axis, when I go to write this formula, I know that my x is going to be the positive variable. So I can start writing part of my equation, and I can start with my x minus 4 squared over whatever a is, minus, that's the big difference now, and then I can start with y minus 0 squared over whatever number I decide to put there, and they're always equal to 1. So this has to be my a squared. This has to be my b squared. Remember, the a squared is no longer the largest number. It's the number that goes with a positive variable. A is the distance from my center to my vertices, just like it was before. So in this case, my a is going to be 1 because the distance from here to here is 1. So I know that a is equal to 1. So I can put that in my equation. So let me start a new equation. So I'm going to have x minus 4 squared. I'm going to write 1 squared, which I know is 1, but I just want to see what it looks like. Now I don't have b, but to find b, I'm going to use that equation that says c squared is equal to a squared plus b squared. Oh, hold on a second. So c squared is the distance between my center and my foci, just like it was before. So it's this distance here, which I can either do 4 minus 0 or whatever, and I'm going to get 4 for my c. So I'm going to have 4 squared is equal to 1 squared plus b squared. So I'm going to have 16 is equal to 1 plus b squared. B squared is equal to 15. So b would be equal to the square root of 15. So now I can write, I'm just going to write y squared because minus 0. I don't need to write that. Square root of 15 squared is equal to 1. So my final equation in standard form is going to be x minus 4 squared over 1 minus y squared over 15, and that's going to be equal to 1. Okay, let's try another one. Before we actually graph a hyperbola, we're going to have to talk about what the b is and how the b is important. So when we have hyperbolas, we actually have these slant asymptotes. And remember, an asymptote is the line the graph approaches but never touches. So I have two slant asymptotes that tell me how wide my branches are going to be. And to draw these asymptotes, I'm going to graph where my b is. So in this case, the distance from my center to my vertice would be my a. This distance from my center to the top of my box, I'm going to call it a box, that's going to be my b. And then that's going to tell me how to draw a box. So I'm going to draw a square, and this will make more sense when we do one. Then to draw my asymptotes, I'm going to draw a line that goes from the corner of the box to the corner of the box and passes through the center. So the corner of the box, passes through the center. And then when I sketch my branches on my hyperbola, I am going to start at the vertices, and I'm going to have those branches come close to those asymptotes. And that's how I decide how wide or how narrow my branches are. Up here, it gives you, and these are on point slope. So your K is going to be your Y coordinate. Your slope of your line is either going to be B over A or A over B. In this case, my slope would be rise over run, which would be rise of B, run of A. And that's why I have a slope of B over A. If my branches went the other way, so I went like this and this, remember this would be my A, and then to form my box, this would be my B, so that's why your slope is A over B. Again, refer to the formula sheet if you have a question. So let's actually try graphing one. We're going to start off with a baby one. I want to sketch the hyperbola of 9y squared minus 4x squared is equal to 36. I know by looking at this that I'm not subtracting anything from my x or my y, so I know my center is going to be at 0, 0. So I'm going to write my center as 0, 0, and then I'm going to plot that point. In order to do this, I have to divide by 36 because I want this equation to equal 1. So I'm dividing everything by 36. And so this will end up being y squared over 4 minus x squared over 9 is equal to 1. Now, I know the 9 is larger, but 9 is not the a. The 4 is going to be the a because the 4 is going with the positive variable. So my a squared is going to equal 4, which means a is equal to 2. B squared is going to equal 9, which means B is equal to 3. I might as well find my C while I'm here. So C squared is equal to A squared plus B squared. So C squared is equal to 13, which means C is equal to the square root of 13. Cannot simplify that, so I'm going to leave it. So when I go to find the distance between my center and my vertices, it's going to be 2 units. So 1, 2. We have a vertice there and a vertice there. Oh, no, I'm not. My bad. My vertices, sorry about that. My vertices are going to go with the y coordinate. So I should be going up and down. So I'm going to go up 2 and down 2. So why don't we write the ordered pairs for our vertices in case we didn't have a nice graph. So my vertices, and I'm only going to have one set for hyperbola. My x coordinate is going to stay the same, so that's going to stay 0. My y coordinate is going to go up or down a, which is 2. So my vertices are going to be 0, 2, and 0, negative 2. And I've already plotted those there. My foci are going to be the square root of 13. So let me add a little distance to this page. So my foci, again, my foci are going to be on this line here, and my x coordinate is going to stay the same, and my y coordinate is going to go up or down the c, which is the square root of 13. And for my foci, I can leave it like that, but just so I know how the graph at the square root of 13 is approximately 3.6. So when I go to sketch my foci in here, I'm going to go up about 3.6. 1, 2, 3.6. 1, 2, 3.6. So there's my foci. But remember, these are the points that I'm using to graph it. I'm not using my foci. I'm using these points here. Now to sketch this graph, I'm going to use B. So my B is 3. Remember that 9 goes with the X. That's a left and a right movement. So I'm going to go 1, 2, 3. I'm going to draw a little dot. 1, 2, 3, little dot. Then I'm going to bring out my highlighter. Love highlighters. So I'm going to sketch a box that connects my A and my B. So I'm going to draw this nice little rectangle. So there's my rectangle. Now to do an asymptote, I am going to connect the corner of the box to the corner of the box going through the center. And I'm just going to shoot this down here. And I'm going to pick it up and move it. So that's one asymptote. The other asymptote again is going to go from corner of the box to corner of the box, and it should cut through the center. So we'll pick that one up, move it a little bit. So those asymptotes are going to guide me on how thick or how wide I should make my branches. Remember, my branches are from my vertices, and so that's why I tried to make my vertices the larger dots. So my larger dots are here. These are my vertices, and so my hyperbola is going to go something like this. So there's my vertice, and there I'm going to go out. Now, while we're here, we might as well write the equation of the asymptotes, even though it didn't ask for it. I'm still going to write the equation just to show you how I do it. I am going to start with the formula is going to be y. Then I'm going to do my k, which in this case my k is 0. K, hk from my center. Then it's going to be plus or minus my slope. My slope of this line is my rise over my run. So my rise was my a, which was 2. My run, which was my b, which was 3. So my slope is going to be 2/3. And then I could write x minus 0 because that's my h coordinate. So finally, my asymptotes are going to be y is equal to plus or minus 2/3 x. And those are my asymptotes. Again, it didn't ask for them, but I thought we could practice. Okay, let's try another one. So this one is given to me in the general form, which means it's set equal to 0. And I don't have those binomials, so I'm going to have to put it in standard form before I can graph it. So just like an ellipse, I'm going to put my x's together, put my y's together. Anything that doesn't have an x or a y, I'm going to sort of move off to the side. So I'm going to move this graph out of the way. Let's reorganize. So when I look at this, I have 5x squared. I don't have any other x's. So I'm going to have 5x squared here. And we have minus 16y squared plus 64y, whoopsie, that's really messy, sorry about that, is equal to 144. The 5x squared, I could factor out the 5, but I'm not going to have to complete the square with 5x squared because he's all by himself. So he's just going to stay there by himself. Here, what's different too is I'm going to factor out the 16, but I'm actually going to factor out a negative 16. So I'm going to have this minus sign here. I'm factoring out a negative 16. So this is going to be y squared because negative 16 times y squared will give me that negative 16y squared. But when I factor out a negative 16 here, the sign is going to change. And so now I'm going to have 4y, and then we have plus whatever number I have to add to complete the square. And this is equal to 144. Again, 5x squared is just coming down for the ride. Here's negative 16. Completing the square. Y, this is now a minus sign, so I'm writing down my minus sign. Half of 4 is 2. 2 squared is 4. But I'm not really adding 4. I'm adding negative 16 times 4. So I'm really adding, this will give me a negative 64. So I'm going to have to add a negative 64 to this side. And when I do that, I end up with 80. Now, just like before, I have to set it equal to 0, which means I'm going to divide by 80. So I'm dividing everything by 80. When I do, and I'm still going to divide this 5x squared by 80, divide this by 5, divide this by 5, and I get x squared is equal to 16 minus y minus 2 squared, that's a 2, really bad 2, is equal to 5 is equal to 1. So it's set equal to 1. Now let's write down the information that I need. So I know my center is going to be 0, 2. So let me bring my graph down here. My center is 0, 2, 0, 2. So there's my center. My A in this case is going to be whatever's with the x. So my A squared is going to be 16, which means my A is equal to 4. Again, it's with the x, so it's a left-right movement. So 1, 2, 3, 4. 1, 2, 3, 4. To write those coordinates, I would take my center, which is 0, add or subtract that 4 to my center coordinate, and 2. So I'm going to end up with 4, 2, and negative 4, 2. My b squared is equal to 5, which means b is equal to the square root of 5. So the square root of 5 ends up being about 2.2. And I'm just going to write that so I know how to graph it. That's about 2.2. So to form my boxes, I'm going to go up 2.2 and down 2.2. Oopsie, that was more than 2.2. And here I'm going to make these really big because these are my vertices. These are what I'm going to use to graph. All these other points are just to help me graph. Let's find our c squared while we're here. So my c squared is equal to a squared plus b squared. So c squared is equal to 21, which means that c is equal to the square root of 21. And as a decimal, so I can plot that point, that's going to be about 4.6. So from my center, which I'm going to write those foci points here, I'm going to take my center, which is 0, and I'm going to add or subtract my c, which is the square root of 21, and my y coordinate stays the same, 2. So 1, 2, 3, 4.6. So like here somewhere and here somewhere. So now let's draw my asymptotes in. So to draw my asymptotes, I get out my highlighter. I highlight my box. Remember, I'm using my A and my B. So I get something like this. There's my box. To draw my asymptotes, I'm going to draw a line that goes from corner of the box to corner of the box, going through the center. I'm going to position that in a better spot. And now I'm going to draw my other asymptote. Again, corner of the box, going through the center. Now to draw my hyperbola, I'm going to my vertices, which I made nice big dots. See how they're nice big dots? So I can find them easily. And so I'm going to start at my vertice and I'm going to reach it out to the asymptote. It does not cross the asymptote, it gets closer and closer to the asymptote. Those are called slant asymptotes, by the way, because they're slanted. All right, so now let's write the equation of the asymptotes. Again, it doesn't ask for all this, but I say let's do it while we're here practicing together. Equation of a line is always y is equal to, so I'm going to do y is equal to my k, which in this case was 2. So 2 plus or minus my slope. In this case, my slope is my rise, which my rise is this number here, which is b, so that's going to be my square root of 5, over my run, which is 4. So my slope is going to be the square root of 5 over 4 times x minus the h. So my final answer is y is equal to 2 plus or minus the square root of 5/4 times x. And you can just leave it like that. That's two equations. One would be 2 plus 5/4 x. The other one would be 2 minus 5/4 x. We're just going to leave it like that. And I think we've done everything we can possibly do on this. And there, nice pretty hyperbola. So the last one is using the asymptotes to write an equation for the hyperbola. So this one doesn't ask me to graph it, but I think graphing always helps. So it says the vertices, it says find the standard form of an equation of a hyperbola having vertices at 8, -2, and 8, 8, and having the asymptotes of -7 plus 5/4 x and 13 minus 5/4 x. So let's talk about the vertices first. They are 8, -2. So let me see if I can bring him out a little bit. So 1, 2, 3, 4, 5, 6, 7, 8, -2. So I have a dot there. And then 8, 8, 1, 2, have a dot there. So those are my vertices. First thing I'm going to do is find my center. The center has to be somewhere on this line. Oopsie. Well, let's use a crayon. We've never done that before. Has to be somewhere on this line. Yes? Yes. So when I find the center, I'm going to find the midpoint between those two points. So I'm just going to find the average. The 8 is going to sit, no, sorry, this 8 is going to stay the same. The x squared is going to stay the same. So to find the center, I'm going to take -2 plus 8 divided by 2. So I have 6 divided by 2, and I get 3. So my center is going to be 8, 3. Applying that point, 1, 2, 3, that is my center. And that looks like it's about the center. So I'm happy with that. Now I need to find my A. My A is going to be the distance between my center and my vertice, and I can count or I can figure it out. But when I do, I believe I get my A to be 5. So I can see that if this is a vertice, I know my hyperbola is going to do something like that. So it's going to open up and down, which means the y is a variable that's positive. So I'm going to do y minus 3 squared, because that's my k, over my a, which is squared. So this will be over 5 squared, minus x minus 8 squared over, I don't know b yet, I'm going to have to figure that out, is equal to 1. So I have 3/4 of my equation written just based on the information that, the first part of the information that they gave me. Now they gave me 2 asymptotes. All I really care about from the asymptotes is what the slopes are. So see here, this slope is 5/4. This slope is -5/4. And that should make sense to you, because when we wrote the equation back here, let me see if I can go back here, we just wrote it as plus or minus. So one would be 5/4, the other one would be negative, well, square root of 5/4. So this one, my slope is 5/4. And that's what I care about. So I have to figure out if it's A over B. Well, this is my rise. If I were to draw these boxes, this would be my rise. And I don't know why it keeps on fighting me. This would be my rise, which we just said was 5. And then this would be my run, which will be my B, which is what I don't know. So that's what I'm looking for. So I'm going to say 5/4 is equal to 5 over some number. Well, this one's fairly easy because the 5's match, which means that x has to equal 4. If it wasn't that simple, you would just cross multiply and solve. So that means my B, I should have done B instead of x, B, so B would be 4 squared. So then my final answer for this is going to be y minus 3 squared over 25 minus x minus 8 squared over 16 is equal to 1. Just highlighting that the only thing that's really important for finding your A and your B when you have the asymptotes is the slope. These other two numbers really don't matter. I mean, they matter to draw the equations, but I don't need them to find the A or the B. Okay, and lastly, let's talk about how we would identify a classing a conic. We've talked about this a lot when we've done this. When you have a conic in what's called its general form, it's set equal to 0. So you would have ax squared plus cy squared plus dx plus e plus f is equal to 0. So the a is the coefficient of x squared, the c is the coefficient of y squared, and they're skipping b on purpose. Don't worry about it. You'll figure that out later in your mathematical career. The d is the coefficient of the linear x, and the e is the coefficient of just y. F would be your constant. What all you're going to notice is see how every single one of these just have A and C. So when I go to classify a conic, I just care about what is squared. All this other stuff doesn't affect the shape of the conic. It just tells me where that conic is located. So if A and C are the same, so both variables are squared and they're the same, it's a circle. If only one variable is squared, so you wouldn't have a C or you wouldn't have an A. If only one variable is squared, then it's a parabola. If these are both squared and they're not the same, and they're both positive, they're both negative, then it's an ellipse. If one's positive and one's negative, then it's a hyperbola. So these are very simple to do. When I'm looking at these equations and I want to classify them, I'm just going to look at whatever squared. So I go here, x is squared, the y is squared. I see that this one is positive, this one is negative, which means this whole thing is a hyperbola. That's it. That's all I have to do. Looking at the next one. I see that I have the x squared. I see that the y is squared. I see that this one is positive. I see that the other one is positive. And they both happen to be, the coefficient both happens to be 1. Since they're both positive, same coefficient, then this is going to be a circle. Looking at the next one, I have x squared. I have the x squared, but when I look through the rest of the equation, nothing else is squared. I only have one variable squared. If only one variable is squared, that makes this a parabola. And finally, the last one, I have 2x squared and I have 3y squared. So they're both squared. They're both positive. Positive, positive. They are not the same. One's a 2 and one's a 3, so they are not the same, which makes this an ellipse. And it's really that easy. All right, we will see you in class. Hope to catch any questions that you might have. Thanks for watching.